Hello and welcome to the second part in the training teaser on measuring, uh, identifying one ball in 12, which is either heavier or lighter than the other 11, and trying to achieve that in the fewest number of measurements. So you have a scale. If you haven't already watched the first part, go back and please watch the first video on this. This is the second part of the logic. Um, so. Uh, and as I stressed in the other video, I recommend when you solve this problem to try to do it yourself and then look at the first video for some hints on how to go about doing it. And this second video is just the continuation of working through the logic. Okay, so so this part is when we already did in the previous video. We looked at what happens when we took 4 of the balls and compared them to another set of 4. So let's say we took A, B, C, D, compared them to E, F, G, H, and they turned out to be identical. Well, when they're identical, we then worked with the remaining 4, because among those remaining 4 was the odd ball out. So in this scenario, we're going to now explore what happens when they're not equal. Okay. So in that case, if that happens, then we know that we know that I, J, and K are actually like standard balls. We don't know among the A, B, C, D, E, F, G, and H which is the potentially heavier or lighter ball, but we do know that it's not among the I, J, or K, or L labeled balls. So given that, we can actually make use of that. So actually there's one hint on this part of the logic. So in the first measurement, we measured 4 balls against another set of 4 balls. And then we're now in the branch of the logic where we have to figure out what to do when they're not equal. One hint I'm going to give you, and so if, take this hint, try to work through it if you haven't already, is to consider taking another measurement and somehow incorporating one of the 4 standard balls. So that's hint 1. And then the second hint, so go off and solve it if you can with just that hint. The second hint now is you're going to do that with measuring 3 balls against another 3 balls. Okay, so now I'm actually going to solve the problem. So what we're going to do for our second measurement is we're going to take 2 balls from the first batch and take 1 ball from the second batch, and we are going to weigh it against 1 ball from the first batch, 1 ball from the second batch, and then 1 standard ball. Okay? So we've kept 2 of the original from the left-hand side, and we moved 1 of them from the left-hand side to the right-hand side, and we brought in 1 from the right-hand side, moved it to the left-hand side, and we brought in a new ball. Okay, so I'm actually going to work through this with the scenario where one side is heavier than the other, and that's totally legitimate because we could just reverse it if it turned out that I'm going to say like A, B, C, D is heavier than D, E, F, G, H. If that's not actually the case, you could just say, well, I'm going to relabel the set to have it such that A, B, C, D is the heavier set. Okay, and so now we're going to work through what happens when I'm measuring these 3 against those 3. Okay. Okay, so in that second measurement, where we measure A plus B plus C versus C, F, and I, here the possible outcomes are basically they weigh the same or they don't weigh the same. Okay, so in the case that they weigh the same, but given that the first measurement where this set was heavier, if it's so there's case one is it's equal. Well, that implies that either C is the heavy ball or G or H is a lighter ball. Okay, now why is that? Well, we had before that A plus B plus C plus D was heavier than the other 4, and now we have that they're equal. I'm sorry, it's not C, right? It's actually okay. I have to change that to black. How do I change this to black? Oh, here we go. Okay, not C. I meant D. Sorry about that. Okay, so if they're equal, then that means that the balls not weighed somehow had messed things up. So it's either D is the heavy one or G or H is lighter. Now why is that? Well, what if we had actually used, if it had been C, that wouldn't have made sense, because here C caused it to be heavier, but here it ended up being equal, and that's not the case, because it can't be one of the balls present. Similarly, the same kind of logic can be used for G or H. G or H were present here, they're not present here. Therefore, when these are all identical balls, it has to be one of the not present balls. Okay, so if it turns out that it's indeed the case that on our second measurement we get from this measurement we get them to be equal, then either D is heavy or G or H is lighter. So we can then do our third measurement. Our third measurement can be measuring G versus H. If we find out that they're equal, if that measurement is that they're equal, that implies that it had to have been D that was the odd one, and it's heavy. If, on the other hand, G is heavier or H is heavier, then it's whatever one is the lighter one is the oddball out, right? Remember that we've concluded from this logic, when these are equal, that because our first measurement had these as all being heavier than these, either C was heavier or G or H was lighter, and then when we measure G versus H, if they're not equal, it's the lighter one, which is in fact so if it's, for instance, if it's G is bigger than H, then that implies that H is the oddball, and if it's less than, then that implies that it's G. Okay, so in this way, you can see that we did one measurement for measuring these four versus those four. Second measure, where we took 3 and measured a different set of 3, where we introduced one of the standard balls. And then the third is just to measure G versus H in the case when they're equal. Okay, so now we're going to go instead and look at case 2 from the second set. In case 2 is when so case 2 is when, let's say, they're not equal, and again we can just pick one of these 3 to be bigger. So let's just say we pick the case where this is bigger. So if that's the case, then that means that either so if in fact that A plus B plus E is heavier than C plus F plus I, well then that implies that either A or B was heavier, because in the first measurement we had this side being heavier. It couldn't have been that E was the heavier one. Or we also know, by the way, that I is standard. So, and then we brought C over to the other side, or F is the heavier one. So again, we have kind of the same sort of logic. If they're not equal, in fact, if they're bigger, then that implies A or B is heavy, or F is light. And so again, we take the 2 that could be the same and we measure them. So our third measurement in the case 2 is to say, let's do A versus B. And then again, if they're equal, then that implies that the answer was that F is the light one, F light. Or if it's A is bigger, then that means that A was the heavier one. Or if B was bigger, so if it's less than, then that implies that B is the heavier one. So in this way, you can see that by, again, doing another set of 3 measurements, we've measured these 4 being heavier than these 4. We measured these 3 being heavier than these 3. We can just do a third measurement and we can quickly deduce either was it which ball it was that was light, or which ball it was that was heavy, given the outcomes of those measurements. Okay, so that concludes this puzzle, you can now see that in all possible scenarios. And by the way, let me just summarize one thing. I could have, again, I want to reiterate, I could have switched this to being less than, and this one being less than, and gone through this similar logic. I've just gone through the case where I've just labeled this one bigger and this one bigger, and you can just verify for yourself that the other ones work. So we've now gone through and shown that with a set of 12 balls, all of them being identical except for one of them being slightly heavier or lighter, we can, in a sequence of 3 measurements, determine which ball it is, and we can determine whether or not it's heavier or lighter. So that's quite a neat logic puzzle, and you can imagine extending it to more complex systems. But hope you've enjoyed that puzzle, and there's more to come.